अस्सलाम वालेकुम स्टूडेंट्स। हमारी जो नेक्स्ट वीडियो है उसमें बहुत ही इम्पोर्टेंट क्वेश्चन हम डिस्कस कर रहे हैं। डिफाइन द कैरेक्टरिस्टिक ऑफ द वेव्स एंड प्रूव वेवलेंथ और लैम्डा इज इक्वल टू वी मल्टीप्लाई बाय टी। तो स्टूडेंट ये बहुत इम्पोर्टेंट क्वेश्चन है, आए इसको देखते हैं कि इसमें जो चीज़ें हैं उसको हम कैसे समझ पाते हैं। तो सबसे पहले हमारे पास लिखा हुआ है टाइम पीरियड। ना व्हाट इज टाइम पीरियड? तो टाइम के बारे में तो हम पहले भी पढ़ चुके थे, हमने चैप्टर्स में भी पढ़ा था टाइम। लेकिन यहाँ पे टाइम पीरियड का मतलब ये है कि अगर एक वेव अपनी कंप्लीट ऑक्सीलेशन करती है, वन ऑक्सीलेशन करती है, उसमें जो टाइम लगता है दैट इज कॉल्ड टाइम पीरियड। आइए इसकी डेफिनेशन देखते हैं। टाइम पीरियड इज Time period, capital T, is the time taken for any one point on the wave to complete one oscillation. Its SI unit of time period is second, and it is denoted by capital T. That capital T is different from small t, because here we are discussing. You can see the cursor I have, you can see on the cursor, I'm starting that this from this point to this point. When a wave complete this from this point to this point, that time is called time period. Right. अस्सलाम वालेकुम स्टूडेंट्स। हमारा जो नेक्स्ट क्वेश्चन है वो बहुत ही इम्पोर्टेंट है। डिफाइन कैरेक्टरिस्टिक्स ऑफ वेव and prove lambda is equal to V multiplied by T. Now we start from time period. Time period is denoted by capital T, and this time period is different from the time when we used to take the time. But this time period mean if a if a wave complete one oscillation, that is equal to time period. Now here the definition, the time period T is the time taken for any point on the wave to complete one oscillation. One oscillation complete from this starting point where you can see the cursor, and from this to this end. Now this from the when the wave come from this point to this point, that time when we note, that is called time period. Its SI unit is second, but it will denoted by capital T. The formula for time period is equal to T is equal to 1 upon F. Here F is the frequency. Now the definition of frequency. What is frequency? Frequency is the number of complete waves produced by the source per unit time. It is denoted by F, and its SI unit is hertz or cycle per second. Now this is the source. So when a, a wave start from this point, and from here it is half wave, not complete wave. So when it go down and then come back on the same equilibrium position, that is called one frequency. And this number of waves produced in 1 second. If in 1 second one wave produced, their frequency is different. If in 1 second two waves are produced, their frequency is changed. And its formula is F is equal to 1 upon T. Now, the third thing is wavelength. Now, the distance between starting point of the wave and the second equilibrium point. That distance is called wavelength, and it is a Greek letter, and we read it lambda. Now, the definition of wavelength. The wavelength is the linear distance between two successive crust or trough in a transverse wave. Again, this we are discussing as transverse wave. If this two successive crust, or the distance between two successive crusts, is called wavelength. Or we can say, if we have a longitudinal wave, two successive compression or rarefaction in a longitudinal wave is called wavelength, and it is denoted by the word lambda. This sign we read lambda. An SI unit of a lambda or wavelength is meter. So we have explained you three terms. Time period, its formula is T is equal to 1 upon F. Frequency, its formula is F is equal to 1 upon T, and its unit is Hertz or cycle per second. And the third thing we have explained you, that wavelength. It is a linear distance between two successive crusts or trough, and it is denoted by a symbol, Greek symbol lambda, and its SI unit is meter. Now we are discussing here the wave velocity. Wave velocity is denoted by capital V. The distance, the distance traveled by a given point on the wave, such as crust, in a given interval of time. यानी एक जो वेव है वो कितनी उसकी स्पीड है, उसको हम कैसे फाइंड आउट करते हैं. द स्पीड ऑफ द वेव कैन बी is equal to distance travel upon time. Now we are we want to prove that value lambda is equal to v multiplied by t. So this derivation we are going to solve here. So for that we take the distance travel lambda, because that is the distance from starting point to one complete oscillation of the wave, and time taken is capital T. This is the formula for calculate the speed. V is equal to S upon T. Now here we have taken S, mean distance, is equal to lambda or wavelength, and small t is equal to capital T to complete one oscillation. Now we can change this above equation. V is equal to S upon T into V is equal to lambda upon T. Now in the above we have read 1 upon T is equal to frequency, mean F. So we replace 1 upon T by F. So our equation become V is equal to lambda F. If we again change this F into 1 upon T, so 1 upon T multiplied by V. So that equation again we can prove lambda is equal to V multiplied by T. That is the derivation of wavelength or calculate the wave speed. For example, we have to find out the velocity of the wave. So we need to know what is lambda and what is time taken by the of one oscillation. By that we can find out the wave velocity. If we want to find out the wavelength, mean a distance traveled by a wave, it can be calculated by V multiplied by T. Here v is the speed of the wave and t is the time of one oscillation. Now, the SI unit of wave speed is measured in meter per second. So this is very important question. So you have to copy down or learn these important term. What is time period? Its unit and its formula, frequency. It is very, very crucial for this chapter also. Wavelength. These are very, very important. And this small derivation, practice it twice. So you must note down this question and make this figure also, that you can understand better.